Python doesn't actually need class inheritance to apply polymorphism. Instead, it uses a powerful concept called duck typing. The idea is simple. It walks like a duck and quacks like a duck, then treat it like a duck. Here we have an email class with a send method for dispatching emails, and an SMS class also with its own send method for texts. Two completely different things. But what if we want a single method that notifies clients by whatever channel they prefer, email or SMS? One client prefers email, another prefers text. One customer wants email alerts, the other prefers SMS. So when you call this over here, email has a send, SMS has a send, and when we run that, you can see sending an email and sending an SMS. What you can do is call this notify method right here, pass in the email object, then pass in the SMS object, and it will call the send method for you automatically, so you don't have to write it out manually every single time. No repetition required. The send logic now lives in one place, written once inside this single function. Notice though, this function is not a type of any object. It's not inheriting from email or SMS. What it does is, whatever you pass in, whatever variable arrives, it simply tries to call the send method on it. Since both classes have a send method, it just works. Let's try it. We run this first, so we don't get any output yet, and now we call our notify function. And there it is. Notify sends an email and an SMS. This is Python's take on polymorphism, where other languages like C# are far more strict. In C# you have to declare an interface and wire everything up. With Python, you can pass in pretty much anything. As long as it has the send method, Python will execute it. You never had to declare it as a type of SMS or email. None of that was needed. You passed it in and it ran the send method. Done. Now, what if the SMS class used a method named sendSMS instead? If that were the case, let's see what happens. Think about it. Will it work? Take a guess. Running it now. No, it breaks. The error says the email part worked fine because the method existed. But for SMS, send does not exist. Only send_SMS exists. So the error reads, SMS object has no attribute called send. It fails because the method name does not match. This is polymorphism in Python, but without inheritance. Hope that clicked. Watch this one again if needed, and check out the previous videos on inheritance to really lock in your understanding of Python. Let's take a look at type hints in Python. To understand them properly, let's walk through this example where we have the email and the SMS class. We also have this standalone function. It belongs to no class. Its entire job is to call the send method. This is an example of duck typing, which is Python's take on polymorphism. The idea is, I don't care what type of object this is. I will simply call the send method on whatever you give me. Whatever you pass into this variable, I will call send on it. That's it. That is all it does. Here, we declare a variable for email, create a new instance of the email class, then do the same for SMS, a new instance of the SMS class. The goal is for the notify method right here to call the send method on both of them. So we never have to type it out manually each time. It removes repeated code entirely. When we run this, the notify function executes, passes the email in, calls send on it, then does the same with SMS. Now here is where it gets interesting. Hover over the parameter, and it says it accepts anything at all. So what if you had another object, say another class called something like a phone call, right? But the call class does not have a send method. It has a method called ring, which would print out something like now ringing. So now if you try passing it in, if you create an object here for call and then set the variable equal to call over here, do you see the problem? It has a ring method, but it has no send method like SMS or email. So when you try to execute this, when you say notify over here and hover over SMS, you can see notify accepts absolutely any type. So you might think, well, if you accept anything, this should work fine. But when you try running it, you get an error every time. Attribute error. Call object has no attribute send. The developer passing in call had no idea what to expect. This is exactly where type hints help. Inside the notify signature, you add a colon. This works from Python 3.10 onwards. Add a colon, then say it accepts SMS. Now, when you hover over the method, you can see its signature reads it accepts SMS, but does that mean email is now broken? Will email stop working? No, Python does not enforce it strictly. Even the call object technically runs. Try running it, and you will still see the same error appear. But what it does do is, when you hover, it shows I accept SMS, not just anything anymore. And here you can add another one. Add email as an accepted type too. Now when you hover over the method signature, it reads clearly. Message is either SMS or email. That is exactly what I expect. But Python still will not enforce it. You can still get these errors. You can still pass in the wrong object type. But what type hints do is make your code far more developer friendly. The moment someone starts typing notify, they see right away it only accepts SMS or email objects. So they know not to pass in a call object. Makes perfect sense. Because if you hover over call and check its type here, you can see it is of type call with a capital C. So I hope this makes sense in terms of type hints in Python. Remember, it is soft. Python does not force it at runtime. But it is incredibly useful for anyone consuming your functions, so they know exactly which object types belong here. Just read the colon, and if you need multiple accepted types, use the pipe operator right here to say SMS or email. In Python, you can create objects from classes and discard them immediately. Take a look at this syntax. Notice anything unusual here? They look almost identical, but something is different. Yes, they call different methods, but look closely at this part right here. This is the developer class, a simple one. When initialized, it prints developer object created. Then when you call the work method on it, it prints writing code. So when you do developer, then call the work method on it like this. Notice this part is actually creating an object from this class. Let's prove it. Run the code. Watch what happens when this line executes. Let me comment out the other line and rerun it. When this line runs, the object gets initialized. And there it is, developer object created. It was never stored in a variable. Normally you would expect something like this syntax, but here we create the object on the fly without storing it anywhere. And we call the work method directly on it, even though it expects a self object to be present. It still expects something to be there. The object is created by these round brackets right here, and then the work method runs on it. So you get the messages, developer object created, because there's a print statement right here. And then the work method runs and prints writing code, all without ever storing the object. So you did not have to do this verbose version, which does the same thing. But if you store it in a variable, you can access it again later. However, there is a catch. For this to work correctly, you have to remove this part. Because if you leave it in, what happens is you end up storing the return value of the method, not the object. So remove that. If you do not remove it, let me show you exactly what breaks. Leave it in, and you get an attribute error right here. It says none type because you are storing the function's return value. You want to store the class object instead, and then you can say dev.work. That is now a proper developer object, whereas before, when you stored the result of the method, it was none type. That happens because the method does not return anything. When a method returns nothing, Python defaults it to null, which is none. Now, the difference between these two, remove that part. This version creates the developer object and immediately calls work on it without storing anything. But this one is different. Save work is calling it directly on the class. That is a static method. So now let me comment that line out and run this. You can see it just prints saving work. No object is being created at all. The init method never gets executed. That is a static method. That is the difference between a static method and an instance method. For example, you cannot call the work method statically like this. Swap it to work and it will fail. You will get a type error saying it needs one positional argument called self. You could pass a dummy value like none in there. But that defeats the purpose. The code runs, but it is not the right approach. Static methods are the ones you call directly on the class, like this. Static methods work exactly this way. No self-argument needed whatsoever. But if you need to create an instance method and discard the object straight after, do it like this. It creates the object, runs the method's code, and leaves no trace of the object, because it was never stored anywhere. Hope that makes sense. And the key difference between this version over here and calling this static method like this without the brackets is you are not creating an object. You are accessing the method directly on the class itself. You are reaching straight into the class and calling that method directly, no object creation involved. So this one is an instance method being called on a created object. And this one is a static class method. Let's see, inheritance and polymorphism working side by side. These are two separate concepts, and it is vital you understand both. Here we have an employee class, and from that we create a child class called developer. So a developer is a type of employee. The employee simply works. Call the work method, and the employee says, I am working. But a developer does not just work. A developer writes code, which is something entirely different. You know what I mean? That was a bit of fun. Anyway, right? So here we have an employee object and a developer object. And this is where polymorphism comes in. You have already seen inheritance and method overriding. Now, with inheritance, this is important. This is the key difference. Employee has a work method. Developer has a work method. With inheritance, you are overriding the work method and making it do something different. You are saying, developer writes code. They do not just work. They write code. This is where you are changing the default behavior of a method that lived in the parent class. So the parent behaves differently to the child. The parent goes to work. The child goes to school. Both are doing work, but in different ways. The child's work is studying, while the parent's work is the hard graft of writing, say code. Anyway, so now we have two objects being created, and this is where polymorphism enters. This is the subtle but critical difference between them. Both objects are stored in a list. This is a list. You can tell by these square brackets wrapping them. So here we loop through each employee in the list. And for each one, we call the work method. And that is what polymorphism is, looping through the list where each employee can be of a different type, yet they all share the same method name, work. When you call work, you get writing code and working respectively. Polymorphism means the same method name can produce different behavior. As long as they share the same method name, polymorphism works. Inheritance is something different. With inheritance, I could add another employee class here, completely empty, with nothing inside it. Let's call it cleaner, and it is a type of employee. This class has no methods of its own. Now when we create a cleaner and pass it into the list here, you can see the cleaner is working. Through inheritance, cleaner did not have a work method of its own, but it inherited one from employee. The overriding is what developer does. Developer overrides what work means. It does something different, writes code. And polymorphism is being able to call that method through a single variable. You never had to specify which type each object was, not employee, not cleaner, not developer. Polymorphism called work and just handled it. So I hope this clearly shows the difference between polymorphism and overriding a method to produce different behavior versus simply inheriting a method from the parent class. One key concept in Python is that inheritance is not required to call a shared method across multiple objects. Let me show you exactly what I mean. We have a class called printer. The printer class has a start method. Computer has a start method, and washing machine has a start method. But notice something important. There is no inheritance at all. No parent class called machine anywhere. If we were using inheritance, you would typically have something like this. A parent machine class, and each device would declare itself as a type of machine like this. And that parent class would have a start method stub, a method that does nothing on its own. Then printer would inherit from machine. Computer would inherit machine. It would look something like this. You would end up with machine everywhere. Computer is a machine, printer is a machine, washing machine is a type of machine, but Python does not need this. Delete that and delete this. And delete the machine class as well. You are left with 3 completely independent classes. And the only thing they share is a start method inside each. Now you can write a standalone function, not a method, but a function. This would actually be a function, not a method, because it does not belong to any class. It is just an independent function. And all it does is take a machine, any type of machine. Look at this carefully. This is a plain variable, not a class. It is all lowercase. Just a standard variable. I could name it anything. I could have called it something completely random. And it would still work, because inside whatever name we use, it calls the start method. So when you pass a printer, a computer, and a washing machine into start machine, this function will go in and execute the start method on each one as it is called. Notice it is not expecting any specific type. It will take any type you hand it. Absolutely anything. Run this and look at the output. Printer starting has appeared, computer starting, and washing machine starting. All of that with 0 inheritance, just like I showed you at the start. Nothing is inheriting from anything. 3 completely separate classes, and this standalone function does not care about types at all. It simply calls the start method on each of the 3 objects you pass into it. Now, you might be wondering, what if the methods have different names? Will that cause a failure? Let's find out. Let's rename this method to start washing. Now, start washing is not the method being called by the function. So when the object is passed in, we will get an error. And there it is, an attribute error. It says washing machine object has no attribute called start. So this function is fairly straightforward. It does not understand the capabilities of the objects passed into it. It blindly tries to call start, even when that method does not exist. The method name must match exactly for this to work. But I wanted you to see that failure so you fully understand why inheritance is not required here. In Python, you have probably seen methods with a double underscore prefix. Those double underscores signal that the method is private. Private means this method should not be accessed from outside the class. Let's look at a bank account example to see this in action. When a user calls the deposit method on the account, it receives the amount being deposited. Inside, it then calls a private method called validateAmount. Because before anything else, you need to verify that the amount being deposited is actually valid. For this example, we will keep it simple. We will just let the code run. We will not add any logic to block or reject the value. We will simply print a message saying invalid amount, but still allow the deposit to go through. In a real application, you would have stronger logic here. But to keep things clean, here is validateAmount. It can be called like this. Self refers to the class instance itself using the variable coming in. You would then validate the amount, create the bank account object. Then on that variable, call the deposit method. Running this, you can see it is depositing £100. That works perfectly. But now try a negative amount. If we run this now, we should see 2 messages printed. It runs the validate method and prints out that message, then prints this one here. Again, no hard rejection logic, just print statements. Simple print statements for now. And there we go. It says invalid amount. You cannot deposit a negative number because our rule says if the amount is less than or equal to 0, it is invalid. You cannot deposit a negative number. Now, what happens if a user tries to access this private method directly? Like going account dot and trying to call validateAmount yourself. When they try and access the validateAmount method and pass in, say 100, let's comment out the deposit line. What you get is an attribute error. Bank account object has no attribute called validateAmount. Python says that method does not exist. Python simply will not let you in. But here is the interesting catch with Python's private variables. You can still access these private methods. You should not, but you can, because Python uses name mangling. Instead of accessing it directly, do this. Type account dot and then add a single underscore followed by the class name. Type 1 underscore, then start typing in the class name, bank account. As soon as you type that, you can see bank account underscore underscore validate amount appears in the suggestions. Now you can pass in a negative number. When you execute this, Python allows you to call that private method by using the mangled name. The name Python transforms it into. But as I mentioned before, if you try to access it using the original name, look what happens. It actually does appear in autocomplete suggestions, and validate amount shows up as an option. But if you try running it that way, it says it does not exist. Attribute error. It can only be accessed from inside the class itself. Inside the class, it is accessible. Outside, it is blocked. But if you absolutely must access it from outside, do not. That is not the right move. If you found this useful, make sure you like, comment, subscribe, and follow to help the channel grow. Let's break down the difference between protected and private methods in Python, and when you should use each one. Here we have a class called payment. Inside it, we have a pay method, a protected check balance method, and a private log transaction method. And then you can see that credit card payment inherits from payment. The class name in brackets means it is a child class. Child classes inherit all the methods from their parent. In the pay method, you can see it takes an amount and then first calls check balance, then calls log transaction. Log transaction is the private method, and check balance is the protected method. With check balance, the credit card class may need to behave differently. So it says, checking the credit card limit, while a standard bank account would simply check whether the funds are available. In there, you would have some logic to check if the amount is available. But with a credit card, the customer does not have a cash balance. They have a credit limit, so the behavior needs to differ. and you are free to override or overwrite that method. By default, you are changing the behavior, but the log transaction method should not change because the logging belongs to the central payment class. You do not want child classes tampering with that. So you use double underscores there, making it private, and check balance uses a single underscore, making it protected. So when you create a credit card payment object that inherits from payment, then call pay. When you run this, you get checking the credit card limit for £50 and transaction of £50 logged. And then the message, paid £50. The logging section right here is private. The credit card class should not be able to touch that. Logging should be standardized. It should only be controlled by the parent class, while the balance checking behavior can vary per child. In one case, you check the customer's available cash. In the other, you are checking the credit limit tied to the customer's card. Hope that is clear. And essentially what this means is, with the private method, if you try to override it in the child class, try creating a private method with the same name. It does not even show up in the suggestions, so when you try to override it and add the same logic, saying the exact same thing, when you try to run this, you can see that override is completely ignored. If I run this now, even though we tried to override log transaction in the child class with a different message, it was completely ignored. The child's version was never called, but if we change it to a protected method using a single underscore, you can see that the transaction of £50 is now logged from the credit card class. So now the method override is actually working, but we did not want that. We actually want this to use double underscores, so that child classes cannot override it. No matter what the developer does, they cannot accidentally override it from a child. Let's talk about inner classes. That is a class nested inside another class. Think of it like a library class, and nested inside it, you have a book class. The two are closely related. A book on its own does not really make sense without a library. The book belongs in the library. The book class has a read method, and reading it simply triggers a print statement here as a demonstration. So how do you actually create an object from this? You create the library first. Instantiate a library. Then you access the book through the library variable here. Then instantiate the book class, which is the inner class nested inside library. Then call book.read. Run it, and it prints reading the book. This pattern lets you group related functionality together, because a book class on its own may not make sense. It belongs as part of the library. If you enjoy the way I break things down, please like, comment, subscribe, and follow. Check out my other videos where I cover both advanced and beginner topics. Follow me on social media to help the channel grow and reach more people just like you. Your support truly means everything. Every class can have its own initialization method. Here, the book class has an init method inside it, and the book class is nested inside the library class. To create an instance of the book, you first declare a variable for library, instantiate library, then create a variable for book, and from the library variable, create an instance of book. And that book expects a title to be passed in. So you pass in Python basics, then call read, and it prints reading Python basics book, so inner classes can have their own initialization methods. The next thing I wanted to show you is that the library class cannot be accessed directly from inside the book class. Let me show you why. Now, library has an init method too, and we are calling it central library. The book class will try to display the library's name. So you create library equal to the library class, passing in central library, then create the book object. From the book object, you try to display the library name. This code will break. When I run this, it says it cannot find the name attribute inside the book class. That is because the book class is completely unaware of the library class around it. It does not know it is nested inside library. So here's the fix. Down here, inside the book class init method, when you call library.book, you also need to pass the library object in explicitly so that the inner class becomes aware of the outer class. So inside the book's init method, you accept the library object and store it as an attribute. And later, the showLibrary method can then access the library attribute and read the name from it. Now, when you run this, it prints, book belongs to the central library, because the library object was passed in when you created the instance of the book class. And when showLibrary is called, it accesses self.library, which is the library object passed in, and reads the name attribute from it. That is that variable right there. Then it accesses the name attribute on it and prints it out cleanly. Hope that makes sense. By default, just because book is nested inside library does not mean it can automatically access library's attributes or properties. That assumption is wrong. You must explicitly pass the outer object in if you need access to it. The main benefit of inner classes here is grouping related things together. Rather than having two fully separate unconnected classes, book and library, that are clearly related subjects, related topics, you can group them together as a single unit of functionality. You could argue they work fine as separate classes too. But in some situations, inner classes are the cleaner, more logical choice. This is just one example of what you can do, and a bit of extra knowledge to help you get more comfortable with how classes work in Python and the different approaches available. If this has been useful, make sure you like, comment, subscribe, and follow. As always, your support is hugely appreciated.